So this is going to be about how to build Lightning applications on very cheap hardware. I can't guarantee that everything I describe in the next 30 minutes or so represent best security practices, but it's just a way to demonstrate that you can do a lot and build some fairly useful Lightning apps or labs with very cheap hardware. So I'll go over the constraints of using very cheap hardware and how to optimize for different things, and then I'll walk through one example with a Raspberry Pi. Okay, so when you're using, it's not just unfairly cheap hardware, but also maybe something that you want to have be mobile. So if you want something that moves around a lot and or is cheap, so things you might have to deal with are like an unreliable connection. You might not always be online. You might sometimes need to connect to a public Wi-Fi network where you don't have much control over the security of the network, and you don't have a static IP address, and maybe sometimes you don't have enough bandwidth to run a full node. And also, if you're using a very small device or low resource device, you might not have the computational resources to sync a full node. Lightning, we'll look at, we'll approach this problem by separating all the functions that our lab needs to perform, or all the pieces that we need to have a working Lightning app. So, I mean, the basic pieces that we're trying to put together are, a Bitcoin node, hopefully a full node, although that's not totally necessary. We also need to be able to run a Lightning node, and probably something like a web server or something that's accessible from the outside world, so users can actually use our app. And I mean, maybe it controls like a vending machine or some other device. So there are some pieces that we'll look at what we need to optimize for each piece, and figure out how to best put things together. So our first option is to just put everything all on one machine. Put your full Bitcoin node, your Lightning node, and your Lightning app all on unfairly cheap hardware. And in theory, and you actually can do that. People have run Bitcoin nodes with Lightning nodes and apps on a single Raspberry Pi. And it's the most straightforward approach to the problem, but there are trade-offs involved. If you want to have a full node and you don't want to prune aggressively, you're going to need a lot of storage and probably an external hard drive. And even if you manage to get a Bitcoin node and a Lightning node all on one small device, you are still going to deal with the network challenges of not having a reliable connection or having low bandwidth. And that results in unreliable Lightning channels, which means it's going to be hard for people to pay you, and the reason why we build apps is because we want to get paid. So the basic setup, if you want to throw everything just on a Raspberry Pi, you can use Raspbian, or I prefer Ubuntu Mate because it's 64 bits, assuming you have a Raspberry Pi 3. If you don't want to do any pruning with your full node, you'll need an external hard drive or a very expensive SD card, which sort of defeats the purpose of unfairly cheap hardware. And this means you're going to have a power adapter, you're going to have to plug it in, and it's not going to be super mobile. And if you're running a Raspberry or using a Raspberry Pi 2, you'll need to enlarge your swap space. I'm not going to go over how to set up Bitcoin Core or Lightning on a Raspberry Pi, because there have been some really good guides written about how to do that, and they go more in depth than I can go into here today. But yeah, the first link is about setting up a Lightning node with a full Bitcoin node on using LND, and the second one uses C Lightning. So those are good resources. I mean, one tricky point that we would still have to deal with is we're going to need to accept inbound connections. But I'll get into that after. So another option, if you're using cheap hardware, is that you can try to run a Lightning node with a Bitcoin Light or lighter Bitcoin client. Like, you don't need to run a full Bitcoin node to run a Lightning node. As long as both parties are monitoring their own channel, you don't need to actively be downloading every block and monitoring the blockchain. So one option for doing that is if you're using C Lightning, there's something called C as pruned. It's basically a Bitcoin D emulator, and it uses the Electrum network to get headers and transactions. And you're basically not running a full Bitcoin node anymore, so you don't need that much storage space. But the downside of using as pruned is you start revealing information about what UTXOs or what addresses and transactions you're looking for. And once you start asking other servers for information, that starts revealing information about what you're doing yourself. Yes?
Not strictly true, because we process full blocks and we don't push servers for peers.
Wait, sorry?
We process only full blocks and we download full blocks and don't reveal what we are interested in.
Oh, okay. I'm probably wrong about this, but I thought that as pruned submits a Bloom filter to. Oh, okay. Never mind.
What it does, it downloads the block headers from Electrum and then downloads the blocks themselves from
Okay.
So we use Electrum servers only for metadata that is basically about the blockchain.
Okay. Never mind.
But it is a good point.
But doesn't that mean that the bandwidth requirement is the same as a full?
Yes.
Okay.
Sorry about that.
No, that's good. I didn't know that. Okay, so now we get into Neutrino. This is the new light client that was released by Lightning Labs. Uses LND basically. I mean, the old way of running a light client was that a node would, was that a user would upload a filter to a full node to request certain information depending on what addresses they're interested in. But yeah, once you start submitting filters to get information, then you reveal some hints about what addresses you control. So with Neutrino, now there was a recent bit where you can do it the other way around. Every single block can have an associated filter. So it's the client who decides which blocks are relevant based on the filter associated with the block. So the client can download the full blocks from elsewhere through Tor or whatever, and no one, the full nodes that are generating these filters don't need to know anything about what the client is actually interested in. So that's why it's considered privacy preserving. And since all the filter matching is done by the client, you're less likely to miss relevant transactions relative to if you were running like an SPV or whatever. Yeah?
Oh, does the client know exactly which blocks to download?
So every block has, I guess, a filter associated with it that the client can use to match with what they're interested in. So the filtering function is performed on the client side as opposed to the server side. So the full node has the same filter for every single block, and every client receives the same filter.
Right, but how does he select only a few number of blocks?
I can't answer that question, but maybe someone else in the room can.
How does the client know which blocks to download?
How does the BIP 157 filter work?
For you do need to download the full block here. Well, or roll the dice, right? Get that full spot.
Okay. Well, yeah. So Neutrino's here. The downside is that not all nodes support BIP 157. Okay, so regardless of what you're running on your device, if you have a full Bitcoin node and an LND or a Lightning node and your app, you're going to have to open a few ports to the outside world. With Bitcoin, you could run a non-listening node, and you don't have to do port forwarding to get information to your Bitcoin node. But if you're running a Lightning node and you want to have people open channels to, you're going to have to forward your Lightning port. And if you have an app that you want other people to use, you're going to have to forward a port for that. So you're opening some holes in your firewall. On the Raspberry Pi, there's something called an uncomplicated on the Raspberry Pi, you can set up an uncomplicated firewall. There are, this is a pretty good link for how or what the options are for allowing certain ports to go in through the, on the Raspberry Pi. Assuming you're behind like your own home router, you're going to have to configure your router to also do port forwarding, and Bitcoin's full node guide has good information about how to configure different routers. But if we're running a node behind a router, or limitations still exist, because you don't always have access to the router. You might not be on your home router, and you might be outside somewhere using public Wi-Fi, or you might be on your, you might have a node running on a cell phone. So we're going to look at, so previously, or that was kind of how to put everything all on one single device, hopefully a very cheap one. And now we will look at separating the different pieces. We don't have to have a Bitcoin node running on the same machine as a Lightning node, and we don't have to have a Lightning node running on the same machine as our app. So we'll look at how to separate these pieces now. So with C Lightning, you can just use a remote Bitcoin node. There was spruned, which still downloaded everything, but you can have a Bitcoin node running elsewhere. You just have to set up the RPC username and password. This in the Bitcoin core repository, there's a Python script for generating a unique password or a hash of password and storing that instead of storing it in plain text in your configuration file. So that's pretty straightforward. Oh, you still need to install Bitcoin Core in order to use a remote Bitcoin node, because C Lightning uses the Bitcoin CLI. But you don't have to actually run the, or you don't actually have to run the Bitcoin node or like download the blockchain on your Lightning node. You just need access to the command line. Okay, so with LND, it's also very easy to, well, actually with LND you can't use a remote Bitcoin node right now. But You can have a remote Lightning node. In the LND configuration file, you specify the public IP address of your node, and LND will generate a TLS certificate when it runs, and you just copy the certificate to the remote client, which is going to be your app, and load up the certificate when you want to access the LND node. Okay, so given that we can separate these things, I'll walk through a very simple, dumb example. So what we're trying to do here is we're trying to have an app. We're trying to have the app be as mobile and light as possible, and it'll and the Lightning node and the Bitcoin node don't need to be on the same piece of hardware as our app. So this is a Lightning peep show. It's just a Raspberry Pi camera, or it's a Raspberry Pi with a camera attached. And the idea is we want people, users, to be able to come here and pay with Lightning and view a live stream from the camera, depending on how much they pay. It's like those like old-fashioned like Nickelodeon things where you put a nickel in and then you watch a short clip. All right, so the hardware is a Raspberry Pi. You can the app we're using for streaming video is called Rasppi still, and then we have and then we run MJPEG Streamer. These are all fairly standard apps that you can download on the Pi. And this just takes a bunch of pictures and converts it to a stream buffer and serves it up on port 8080. You can run a different app. You could run like an app that controls the I/O pins on the Raspberry Pi if you want to control a vending machine instead. But here we're just running a camera app. Then you have your web app. The web app ideally should sit on something with a stable connection so that users can visit it and know where to go. Because your camera might be attached to a drone or way off in the middle of nowhere with an unreliable connection. So you can have a web server that talks to this Raspberry Pi camera no matter where it is. So the way to do that is to create an SSH tunnel from the Raspberry Pi back to the server. So I don't know if you can read this, but it's just an SSH command that creates a reverse tunnel. You run it on the Pi and it connects to the web server. So now the web server has a port that acts as a tunnel to the Pi, no matter where the Pi is. And you can set this as a cron job or something, or auto SSH will actually automatically create or auto SSH will automatically reconnect if it times out or gets disconnected or changes networks. Yeah.
I think you had configured in the Bitcoin core allow IP. Like the server needs to know in advance which IPs are going to connect to them. Is there any way you can work around this, or is something?
Well, we're hopefully going to have a Lightning node on something with a static IP. It's just the app itself. Well, the app itself can run on the same machine as the Lightning node. We're just looking at the end device that's gonna like run around taking pictures that won't have a static IP. Does that make sense?
So you're saying that the Lightning server would be somewhere else, like the local
Right.
device?
So the Lightning node sits between the web server and the Bitcoin node. So the Bitcoin node needs to allow RPC connections from something with a static IP. So that'll be your Lightning node on a static IP, and the web server hopefully should have a static IP so that people can find it.
Okay, so what's regarding the keys? Like the analytics can have keys and sign transactions, sending them to the Lightning server?
So the way this works here is you have a Raspberry Pi that has a persistent tunnel back to, in this example, the web server. So this guy is always phoning home on the same port. Like even if this guy changes networks or whatever, it's always going to phone home. So you can always find this guy in the same place even when it's moving around. Okay, so on the web server, we can now build an app that acts as a relay, but it's a gated relay. It doesn't just automatically relay everything it receives from the device over to the customer. It'll rebroadcast it only if it receives a payment. So we have an app. On the app server, we can look at port, let's say 1234, and that's where the mobile device is phoning home. We can decide whether or not to let our customer see what's coming in on this port based on whether or not they pay. So the customer shows up and requests an invoice, and in this example, we're just using the L&D API. The specs are here. It's fairly simple. It's just a get invoice command. So this app is connected to the Lightning node, the L&D node, and fetches the invoice. The invoice is forwarded to the customer, who now has their invoice, and hopefully they have Lightning running on their phone or something, or a Lightning wallet on their phone or whatever, so they can pay the invoice. When they get the invoice, a WebSocket is opened, and here I was just being lazy. The WebSocket should have a unique identifier. I just used the R hash from the invoice, and in the meantime, this app here can run a command called subscribe invoices, and this is also part of the Lightning API. It just opens a socket to the Lightning node, and any updates to invoices will automatically get pushed back to the app. All right, so this person has a socket open, and the app has a socket open to the Lightning node. And once the invoice is paid, the Lightning node will push that information to the app, and the app will know that it needs to update information for the client with this associated hash. So here it because it knows that the customer paid, it can now push this information and open up the socket so the customer can watch the cartoon that's coming in from or the camera stream that's coming in from the remote device. So the cool part about being able to separate all the different pieces is that now we can have there are a lot of different possibilities. We have a lot more flexibility when we can think of all these pieces as individual components that can run on different machines. This app can open many WebSockets with different identifiers depending on the customer's R hash. So lots of people can pay to view the same stream, and we don't have to overload our Raspberry Pi by having it broadcast to all these users, because the app itself is going to serve as a relay that rebroadcasts whatever the device is sending over, depending on whether or not these people pay. And at the same time, the Lightning node, it can run on the same machine as the app, or it can be off somewhere else on a remote server, and it'll still be able to open a socket to the app and let the app know when invoices have been paid or expired or whatever. Right, so now, there are a lot of possibilities now. We can have many Lightning nodes getting information from the same Bitcoin node. We could even have many different apps running off the same Lightning node, but Lightning nodes are so light and they don't use many resources, so you can have multiple Lightning nodes. And each app can control lots of devices, and that's it.
What are the give you to have redundancy with Lightning nodes?
It's not redundancy. It's just if you want to have lots of different Lightning nodes pulling information from the same Bitcoin node, because ideally you want to run your own Bitcoin full node because don't trust, verify.
Yeah. Right.
But there's no reason to have a unique Bitcoin node for each Lightning node. So you can have lots of different Lightning nodes with lots of different apps if you want to have. Yeah. Yes.
When having multiple Lightning nodes, multiply out X in terms of routing and channels.
Well, I mean, each node is going to create unique channels to whatever it is it wants to have as peers.
Right, so if you have one Lightning node as a network, you've got a bunch of channels.
That's true. I mean, you could.
If you've got multiple nodes, it's spreading across the channels.
That's fair. Yeah, I guess I was thinking of if there are different wallets that maybe you don't want the same person to control. Like maybe one Lightning node is a shared wallet between me and my brother, but I mean it's up to the user. I can't. There are trade-offs associated with all configurations. Yes.
So I think you gave an example. So IoT devices are actually the receivers, right? I mean the server issuing invoices on their behalf, right?
Yeah. Well, it's a tunnel, so instructions can go both ways.
Yeah. Okay, so my main question is, let's say I want to have the devices paying, right?
Mhm.
So what's your take about holding the keys and signing transactions and sending them to the server? Is there what's your comment on that?
Well, the Lightning node is isolated from the device.
So it's isolated by typically the Lightning node also holds the wallet. See Lightning, for example. Well, it typically holds the wallet itself.
Yeah. Right. So if someone steals your drone, they don't. I mean, they have your drone, but they can't access your Lightning wallet.
Yeah, but what if, I mean, can you think of a scenario where you do want an IoT to hold its keys?
Sure. If you can still run the Lightning node and the app together on, say, a vending machine, and that's possible too. Yeah, this example is just to show like what you can do with with very little hardware.
Yeah.
Yep.
So, what happens if my Lightning node gets compromised? Because, I mean, if it's compromised, I basically have the credentials to the Bitcoin RPC, and I can access the Bitcoin node, right?
Well, hopefully all your Bitcoin is in cold storage somewhere, and you're not running a hot wallet on your Bitcoin node. I mean, a Lightning node is a hot wallet, so it's at risk. But
So you suggest basically that the Bitcoin node doesn't store any funds, it's just like working there to like operate the blockchain. Yeah.
it's just for like
And the
information.
Lightning node
Yeah.
is basically only a wallet and node.
Yeah. Yep.
So for the web server to talk to the Lightning node, you need to do some kind of like macaroon transfer, right?
Right. Well, if you're using LMD, yeah.
Yeah. Do you have any recommended ways of how that transfer should go down? I mean, do I like is that the kind of thing where I just need to like file sync it, or is there some like good way of doing that via some kind of like authentication?
To be honest, I just used the code that was provided on the Lightning API example.
Gotcha.
Okay.
Thank you.